Okay, so now that we've looked at some of our basic definitions, so now what we want to do is talk about some of our different sampling methods. And so again, I mentioned this a little bit earlier that some of the things that we're looking for is we want to make sure that the sample is representative of our population. And one way that we can do that is we want to try to make sure that our sample is random. So again, we want to make sure there's no bias involved in our sample. So to make sure our representative sample is random, so what we want to do is make sure that each person has an equal chance of being selected. And so some of our possible ways that we can do random sampling, and the most simple one would be what's called the simple random sampling. So for this one, it's almost like just imagine putting a number for each person, throwing their name in a hat, pulling out the hat, pulling a number out of the hat, and then just keep going until we get the total number that we're interested in. So again, with this method, there's definitely no bias or anything like that because we're just randomly choosing numbers. We're not looking in the hat to decide which numbers to pick or anything. So this is a perfectly valid method. So another one that we can talk about is what's called a stratified sample. So for this, what we're going to do is divide the population up into groups or strata, and then choose an equal number from each of the different groups. So a good way to think about this one is if we were in class right now, we'd have 5 tables in our class with 4 students at each table for a total of 20 students. And so what we would decide to do is choose 2 students at random from each table. So we would basically put the numbers 1 through 4 in a hat, choose 2 numbers, and whoever those students would be, we would choose 2 from each of those different tables. All right, now cluster sampling, it sounds similar to stratified, so you want to be careful that you keep these separate. So with this one, again, we're going to divide them up into groups, but in this case, what we're going to do is select a whole group. So in the last one, we selected like 2 people from each table. So from here, what we're going to do is actually select that whole table of people. So again, if we had 5 tables in class with 4 students at each table for a total of 20 students, we'd number the tables 1 through 5, throw them in a hat, and we would just pull out, say, 2 whole tables. So we would take everybody from those tables. All right, systematic sampling. So with this one, what we're going to do is have everybody kind of in a numbered list, and we're going to choose some kind of starting point, whatever it happens to be, say the 100th person on the list, and then we're going to jump by the same amount over and over and over. So maybe we jump by 5, we jump by 10, we jump by 50, whatever it happens to be. But we keep going, choosing people off of that list until we get up to the total sample size that we're interested in. Now, if your list is short, you may have to cycle back around to the beginning in order to, fill up the amount of the sample size that you wanted. But again, this is a perfectly valid way to do it. And so the last one is an easy way to collect a sample, but it's far from random. And so this is basically just a convenience sample. So this one could be a matter of just like asking a question of people that you're in class with, because again, they're easy to access. It could be standing outside of a building, just answering, whoever you run into or something like that. So again, we always have to be a little careful of convenience samples because they may not yield a nice representative sample that we're looking for. Plus, if we're kind of asking people questions, we could ignore certain people, so we could introduce some kind of bias into it as well. So again, we want to be careful about convenience sampling. So even though it's easy, doesn't necessarily mean it's going to be a good way to represent our population that we're interested in. All right, so these are kind of the 5 main sampling techniques that we're going to be using. So the big thing we have to be careful of is, what are some of the problems that can occur with samples? And so again, bias is definitely one of the biggest things we have to be worried about. So we want to make sure that our sample is random, representative, no bias, anything like that. That's going to be the best way to ensure our sample data is going to mirror what we're trying to be interested in with our population. So self-selected samples, so these can be a little tricky to use too. So because if they're, if you're offering this up to people, people who feel really strong, or people who, either positive or negative, tends to be the ones that kind of answer self-selected samples. So sample size issues. So again, we want to make sure that our sample is big enough to represent our population. Now it doesn't have to be humongous, but we definitely want to make sure that we get enough people in order to guarantee that we can have good results and things like that. So influencing the responders. So sometimes just the way you word the question can actually kind of make people answer it the way you want them to answer. So for example, if I ask the question, how badly do you think Congress has done? So I've already kind of put it into your head that you think Congress is doing a bad job. So again, wording the questions in such a way can influence the way people actually answer these questions. So causality, so this is something we're going to talk about towards the end of the semester. So this is just a relationship between two variables. And so that does not mean that one causes the other to occur. So they may be correlated, so there may be like a relationship between them, but it doesn't necessarily mean that one's going to cause the other or anything like that. And then self-interest studies are ones that are performed by an organization in order to support a claim that they looked at critically. So like, for example, I put on here, eating candy every day will help with weight loss. And so, of course, we'd like that to be true. But if we look at who actually was the one running the surveys, it was Hershey's Chocolate. So, because of course they're going to benefit if they can convince more people to actually eat candy and stuff like that. So, let's look at a couple examples real quick just to make sure we've got the idea of these. So normally we would do these in class, but I'll kind of walk through them and make sure you understand like where I'm coming up with these answers and stuff like that. So that way you could actually do these on your own. So we're trying to decide whether each of the following sampling methods that we used is likely to produce a representative sample and explain our reasoning. So if we're trying to find the average annual income of all adults in the United States, we decided to sample the representatives in Congress. So is that going to be representative? So no. So because in this case, there's only so many congressmen, they're guaranteed a certain amount of money and stuff like that, and so their salary is definitely not going to be representative of a whole population and things like that. All right. To find out the most popular cereal among children under the age of 10, stand outside a large supermarket one day and poll every 20th child under the age of 10 who enters the supermarket. So that one seems good. So again, like we're standing outside, we're making sure we survey every 20th person as they come in and stuff like that. So this seems like this might give us a good representation of a sample. To find the GPA of all students in a university, use all honor students as the university as the sample. So again, probably not the best idea for this one because again, if you're in the honors college, you probably have to have a certain GPA and things like that to begin with. And so again, this may not actually reflect what the GPA of all the college students actually look like. So for 4, determine the average cost of a 2-day stay in a hospital in Massachusetts. Survey 100 hospitals across the state using simple random sampling. So this is pretty much textbook best way in order to get a representative sample data. So we're using simple random sampling. We surveyed 100 hospitals. Everything's perfect for this one. This looks good. All right, so finally 5. A local radio station has a fan base of 20,000 listeners. The station wants to know if its audience would prefer more music or more talk shows. Asking all 20,000 listeners is an almost impossible task. The station uses convenience sampling, surveys the first 200 people they meet at one of the station's music concert events. 24 people said they prefer more talk shows. 176 said they prefer more music. Do you think that this sample is representative of the entire 20,000 listener population? So in this case, if the radio stations consist of both music and talk shows, the fact that they did this at just a music event pretty much tells us that it's going to be no, because obviously if you went to the music event, you're probably more interested in music than the talk show side of it. So this definitely wasn't a good way in order to do this sample, and it's definitely probably not representative of the group of radio listeners as a whole. All right. So again, make sure you could go through these and think about these on your own. Think about why I answered the way I did and stuff like that for these, and make sure you can kind of do them on your own. So for practice 2, with this one, what we're going to do is try to see if we can figure out the appropriate sampling method. Then I have one for you guys to work on your own as well. So a study is done to determine the average tuition that Hood College undergraduate students pay per semester. Each student in the following samples is asked how much tuition they paid for fall semester. What is the type of sampling in each case? So in this case, a sample of 100 undergraduate Hood College students is taken by organizing the students' names by classifications. We've broken them up into groups. So we've got freshman, sophomore, junior, and senior. And then we selected 25 students from each of these groups. So notice we didn't select the whole group or anything like that. We just selected certain amounts from each group. So if we remember, the two that dealt with groups were our stratified and our cluster. And stratified is the one where we take just a few from each of the different groups. So in this case, our first one is going to be a stratified. All right, so for B, a random number generator is used to select a student from the alphabetical listing of all undergraduate students in the fall. Starting with that student, every 50th student is chosen until 75 students are included in the sample. So again, this is the one where if we look back, we're going to start off with a certain number and then keep going in that order throughout. So this is going to be our systematic sampling. Completely random method is used to select 75 students. Each undergraduate student in the fall semester has the same probability of being chosen at any stage of the sampling process. So this is going to be our simple random sample. So imagine just they threw all the names into a hat. They pulled out 75. So this is going to be just our plain Jane simple random sample. The freshman, sophomore, junior, and senior years are numbered 1, 2, 3, and 4 respectively. Random number generator is used to pick 2 of those years. All students in those 2 years are in the sample. So again, in this case, they're broken up into groups, but we're choosing 2 whole groups, so like freshman and sophomore, sophomore and senior. So in this case, this is going to be our cluster sampling. All right, so finally, administrative assistant is asked to stand in front of the library one Wednesday and to ask the first 100 graduate students he encounters what they paid for tuition the fall semester. Those 100 students are the sample. So again, this one's going to be a convenience sample because they're not actually like choosing them based on some number or anything like that. They're just choosing the first 100 that walk in. So again, there's no guarantee that this is going to be random. There's no guarantee it's going to be representative. It is easy. So in this case, that would be our convenience sample. All right. So again, make sure you understand where these are coming from. If you have any questions or anything, let me know. So work on practice 3, and then again, we'll share our answers in practice 4. Oh, actually, so practice 4 is kind of a fun way to demonstrate what each one of these actually look like. So I would like you to try these on your own. So if you get stuck on how to do them, let me know. But it basically goes through and demonstrates what a stratified sample would look like, what a cluster sample would look like, what a simple random sample would look like, and what a systematic sample would look like. And so what I'm going to do is I'm going to make a spot for everybody to share their answers so we can see that even though we're all starting with the exact same set of data, that we end up with maybe totally different answers in the end, which is kind of a cool way to see this one. So let's work on practice 3, practice 4, and then I'll see you in a little bit for 1.3.